Number 12 says find the equation of the ellipse. Okay, so we know that these equations are going to be a fraction plus a fraction where size matters over 1. And now let's draw a quick sketch. The vertices are going to be at plus and minus 5, so like 5, 0, and also negative 5, 0. And the foci are going to be at positive 3, 0, and negative 3, 0. So this ellipse looks like it's going to be a horizontal ellipse because the vertices and the foci lie on that major axis. Okay? Alright, so let's go ahead and label this as 3, 0, and we'll label this as negative 3, 0. So if that's the case, we know that the center is at 0, 0 because it's equidistant from both sides, both for the foci and for the vertices. So I can highlight this distance between the center and the foci, which is from 0 to 3, and I know that the C value is 3. I also know this value from the center all the way to this vertex of 5, since it's horizontal, otherwise x, which is the same as A, we know that A is 5. We don't know B. But because of the fact that this is an ellipse, which is adding, we can take the subtraction where size matters. C squared is the bigger one squared, which we know that because it's horizontal, the bigger one is 5. And we're going to take away this smaller one squared, which is B. This is what we don't know. Let me highlight that in blue. We don't know this B quite yet. Okay. So C was in fact 3. So we're going to say 3 squared is 9. We're going to say, let me put this 5 squared as 25. And now we're just going to move some stuff around. Let me add the b squared to the right or left side. And let me subtract this 9 over. So 25 minus 9 is 16. And you can see right now, if I take the square root, b is 4. Okay, and we're trying to find the equation of this as far as standard form. Okay, so the center is 0, 0. So we know x squared. We know y squared. They're adding. So it doesn't matter which one comes first, x or y, because they're adding. But we want to make sure that we line everything underneath as far as where the a's go, where the b's go, and where the c's go. Our goal was to find this b because it's basically lining up with the y value. Okay? So that we know we could put b squared in the denominator as 16. Okay? And then a we know is 5, so if we square that, we get 25. And it does validate that the bigger number is with x, showing that it was a horizontal. So sure enough, this is my answer for part A. Let's go over to part B. Part B, they give us the eccentricity. And we know that eccentricity is equal to c over the bigger one, okay, whichever one it is. And I know that the foci are going to be at 0, positive 2, and 0, negative 2. Remember, the foci always lie on the major axis. So this one looks like it's going to be bigger y-wise because you have the vertex here, or vertex here, you have the vertex here, and you have the foci all lining up on the major axis. Okay? Okay, so if we know C is 0, 2, and 0, negative 2, as far as the foci are concerned, again, I can see because they're equidistant that my center is going to be 0, 0. Okay? So if my center is 0, 0, we can go ahead and start writing out x squared. This is going to be plus, again, because they're ellipses, and it's equal to 1. Now I just have to find A and B. Okay? I know the C value. The C value is the distance from the center to a focus, which in this case is 2. So I can go ahead and put 2 here for my C value. And now I just have to see what is the bigger one. Okay, so I don't necessarily know what this value is, but I do know that E is 1/8. They gave me that the eccentricity was 1/8. Okay, so solving this out, let's say our big is our unknown. Okay, And we know because its size matters and it's like this vertically, we know that this is going to be a B of some kind. It's not going to be the A because it would be horizontally bigger because A is with X. It's going to be B because B is with Y. So cross multiply, we get 16. Cross multiply, we get B. So B is 16. Okay? So B is 16. We know C is 2. And we can finally look for A with the equation. Okay, so because we're dealing with ellipses that are always adding, to find C's, we will subtract the bigger squared, which in this case is 16 squared, minus the smaller one squared, which is A squared. We learned that C was in fact 2. So therefore we have 4 is equal to 16 squared, which I believe is 256, minus A squared. And if we move the A to the left, we have a positive A squared. We subtract the 4 to the right, we'll have 252. So A is equal to the square root of 252, whatever that is. Okay. So I know A is the same as my X value. Again, X and Y correlate to A and B, here and here. So A is going to go underneath X, but I'm going to square it, so it'll be 252. And B is going to go underneath Y, but I'm going to square it, it'll be 256. So this right here would be my equation.